Tonight, we go deep in our focus on outer space. First, budget cuts to federally funded scientific programs could impact research being done right here in southern Arizona. On tonight's show, we sit down with the director of the Lunar and Planetary Laboratory to find out if space programs are feeling the pinch. Also, we investigate the threat of space objects to planet Earth. Those stories coming up in just a moment, but first, these news headlines.
The Mexican government is partially funding a health initiative in Tucson at El Rio Health Center. The program is called Ventanilla de Salud and focuses on health education. Lorena Verdugo says the program provides resources and information on preventative and primary care. It does not provide on-site exams.
The service we do provide is the eligibility form, which is in Arizona, it's called the HIA, the Healthy Arizona application, and that's a screening application that screens for either access, PCAP, which is a discount in Pima County, or our sliding fee at El Rio.
The Mexican consulate is giving $32,000 to El Rio Health Foundation to keep the education center working. The funding covers half of the cost of the services, and El Rio covers the rest. The program connects people who visit the Mexican consulate with clinics or services throughout the county. This year, the Mexican government increased its contribution to El Rio by $2,000 because officials say the demand for health services in Tucson is increasing. The U.S. Supreme Court heard arguments today about the constitutionality of California's ban on same-sex marriages. 2 Arizona women traveled to Washington, D.C. to tell their personal story as the court heard the legal arguments. Karen Bailey and Nelda Majors have been in a relationship for 55 years, and Bailey says she hopes the law is overturned.
What it would mean is that, that possibly Arizona would start listening. They would know that the law had been passed. And if they still, and I've heard this, that if states that still refuse, that there could possibly be lawsuits.
Andrew Pugno is the lead counsel for those who want the law upheld. During a news conference in Washington after the hearing, he said this should be a state issue.
Well, our position all along has been that the political process, that means state by state, states deciding for themselves, that's the forum where this debate belongs, and that this is not something that should be imposed by the judiciary, by the courts.
They and others are awaiting the Supreme Court's ruling, and that's a look at today's news.
On February 15th, the world anxiously anticipated the nearby passing of an asteroid named 2012 DA14. Scientists had seen the asteroid coming for months and predicted it would pass close to Earth, but miss. And it did. However, just hours before its arrival, an unexpected meteor flashed through the Russian sky, producing a shockwave and scattering debris that damaged buildings and injured nearly 1,000 people. The Chelyabinsk meteor, named for the area in Siberia where the fireball occurred, illustrates the dangers Earth faces from space objects. The University of Arizona is at the forefront of detecting and observing such objects, and soon will be visiting one of them.
We've actually been able to analyze the trajectory of the object that hit over Chelyabinsk, and it was really coming out of the sun. It was a relatively small object, about 20 meters or 65 feet across, or maybe even just a little bit less than that. So those objects are difficult to find anyway with our current ground-based assets. But also, this object approached the Earth from the direction of the sun. So even if we had a telescope out there looking in that direction, we couldn't have seen it because the sun's brightness would have interfered with it.
Space rocks have had a significant role in life on Earth. Lesser collisions have destroyed broad swaths of habitat around the impact site. Major strikes have influenced the entire planet before humans were around to notice.
We've looked at these past activities. We see the meteor crater in northern Arizona. That was 50,000 years ago. The asteroid that hit the Earth and probably brought the dinosaurs to an end was 60 million years ago. These are historical facts for most people, but this really brought it home, I think. First of all, we do understand that these things do represent a clear and present danger to the Earth, and that they need to be inventoried, and that there needs to be public policy forged, which allows us to produce a reasoned response. So this also goes to the whole issue of just preparedness and being able to respond to emergencies. And I think that we've done a pretty good job of that in the United States, but nevertheless, it also causes us to focus on the ways that we might be able to mitigate or at least prepare for these sorts of things. In the event of even just understanding that something like this is coming in the last day or so, it might be something as simple as it's going to happen, stay away from your windows when the explosion occurs. In other cases, it may involve evacuation.
Some of the most valuable knowledge we will learn about asteroids in the next decades will come from the U of A's Asteroid Visitation Project, known as OSIRIS-REx. That stands for Origins Spectral Interpretation, Resource Identification Security Regolith Explorer. This NASA mission will touch an asteroid and bring a sample of it back to Earth. If all goes as planned, a spacecraft will, in 7 years, acquire a sample from the surface of an asteroid called 1999 RQ-36 and return it to Earth. Headquarters for the mission will be at the University of Arizona.
OSIRIS-REx is going to be a pioneer in a lot of ways in dealing with near-Earth asteroids. Probably the first thing that we want to do is we want to understand how to predict the orbits of these much better so that we can say for certain whether a given object represents a real danger to the Earth. Right now, the factor that prevents us from being able to predict these orbits beyond about 100 years is something called the Yarkovsky effect. It's the absorption of light by the asteroid and the re-radiation of it as heat. And that heat acts as a little rocket thrust, and that actually can change the orbit of the asteroid over a long period of time. If we understand that much better, it will improve, we believe, or we hope it will improve our ability to predict the orbits of these objects. The other thing that I think the mission's really going to be a pathfinder for is creating the technologies to navigate and work around these small objects. And we're working out the techniques, we're working out the processes, the hardware that we'll need to be able to successfully navigate in the vicinity of the asteroid. Any future mission to investigate a hazardous asteroid or to mitigate the impact of a hazardous asteroid is going to have these kinds of techniques well established before they do that, and that's a really great thing for the OSIRIS-REx mission to be working on.
The objective of the OSIRIS-REx mission is to better understand the origin of life and how planets form. The lessons learned while acquiring that knowledge has implications for future asteroid encounters.
All this information that we gather in the course of developing this mission, understanding how to work around these asteroids, can feed forward directly into planning for any sort of a mitigation activity.
You can learn more about the threat of meteors to planet Earth, including the meteor that burst into a fireball over Siberia last month, on NOVA. For that, tune into this station tomorrow night, Wednesday, March 27th at 9 p.m. Deep cuts to the federal budget, known as sequestration, went into effect on March the 1st after Congress failed to reach a budget compromise. Some of those cuts go to government-supported scientific programs, such as the National Institutes of Health, the National Science Foundation, NASA, and the U.S. Geological Survey. These programs are instrumental in much scientific research, and many universities and university scientists depend upon grants from organizations such as the NSF and NIH to conduct research, and they're feeling the pinch. Here to tell us more about what sequestration means for space funding is the director of the Lunar and Planetary Laboratory, Dr. Timothy Swindle. Thank you so much for coming in today. This isn't necessarily an entirely uplifting conversation to start talking about budget cuts. So why don't we start talking about, first of all, how much of your laboratory's funding comes from the government?
Our laboratory's funding is over 90% federal government. We get a little bit of money from the state, but we are heavily leveraged. So we rely very heavily on NASA in particular.
Yeah, NASA in particular. So how do you think that's going to affect you?
Well, the sequestration is not pleasant. I was at the biggest planetary science conference of the year last week in Houston, and a few days before the conference, there was an announcement that only 50 government scientists could attend. That's government employees, although there was some confusion about that at first, and people were scrambling to figure out whether they still had plane tickets. They eventually raised that to 100 government employees, but that meant that some talks about, minor things like curiosity, the person who actually developed the talk wasn't there to give it because they were sequestered.
Ouch. And how is this affecting your organization?
Well, our organization, the effects aren't too bad so far. Big projects like OSIRIS-REx, they are not taking the sequestration out of that, although they are taking sequestration out of individual scientists' grants, not out of the grant that you have right now, but they are delaying the start of new grants.
And isn't one of the challenges that you have sort of the uncertainty that's surrounding this sequester? We don't really know where the budget cuts are coming, is that right?
Oh, absolutely. We always feel that if we know what the ground rules are, we'll play and do well. But when we don't know what the rules are, it's hard to compete.
And morale, this must be affecting your scientists' morale if they don't know where their funding's coming from.
Well, it does, although actually last week had, I would almost say, more good news than bad news, because the continuing resolution that Congress agreed on for the rest of the year actually includes a boost for planetary science beyond what NASA's proposed budget had been. A year ago, the proposed budget had been for a 20% cut, and Congress, in their continuing resolution, put back in more than 2/3 of that. Of course, then that's going to be sequestered, part of it, but on the whole, it's good news for us.
So on the whole, when you look at sort of what you think might happen with sequester and then the budget upper that you just received, is the Lunar Planetary Lab going to get smaller, or do you foresee in your crystal ball that you might just forge forth as you have been?
Well, we don't see anything that we are going to lose right now. We lost one camera on a Mars mission a year ago when the budget cuts were announced, but right now we look to be in reasonably good shape as a laboratory. I'm sure there are some individuals who are worrying a little bit about where their paycheck's going to come from at the end of the summer.
Yes, it sounds like it. And on OSIRIS-REx, it sounds like that program is safe for now. What about next? What is your lab building up for to go after next? Because presumably you've already got to be thinking about the next big thing.
Oh, we're always thinking about the next big thing, and we always feel that as long as there are competitions for missions, we'll do well. We had the Mars Scout mission, the Phoenix Mars Lander, that we were the lead institution on. We have OSIRIS-REx, but there has been some cutback in the number of competed missions that universities can compete for, and so that worries us. More than what's happening this year is what the possibilities are in the next 2 or 3 years. And right now, they are looking a little grim, but as I say, with last week's news, they're looking better than they did 2 weeks ago.
So I have told people over the years that more instruments to Mars have come from the Lunar and Planetary Lab and the University of Arizona than anywhere else. Am I right? Am I spreading the truth?
I suspect so, although I've never counted it. But almost every Mars mission we've had an instrument on. Curiosity, we don't actually have an instrument, but we have people working on 2 or 3 of the instruments.
Thank you very much indeed for coming in today, and good
Thank
luck.
you. Well, thank you. I hope that we don't need it, but we may.
The Supreme Court considered the very definition of marriage in a challenge to a California law banning same-sex marriage.
We have audio excerpts of today's arguments, reaction from both sides outside the court, a recap from Marcia Coyle, and our own debate.
Then HiRISE examines a spike in home prices, rising at the fastest pace since 2006.
Margaret Warner talks to NPR's Howard Burkus about an investigation into dangerous working conditions in grain storage bins.
Spencer Michaels reports on the musicians' strike that's darkened concert halls from New York to San Francisco.
And we close with a story of the women who worked in a top-secret town in Tennessee during World War II. Ray Suarez sits down with the author of The Girls of Atomic City.
That's all ahead on tonight's NewsHour.
Hundreds of workers have suffocated in grain storage bins over the past 4 decades. Some were teenagers.
When they throw a kid in there with a shovel or a pick and say, knock that corn down, we got to have it out by dark.
I'm Renee Montaigne. Safety violations and a workplace investigation on the next morning edition from NPR News.
While people often use the terms meteoroid, meteor, and meteorite interchangeably, these terms all have different meanings. And what makes an asteroid different from a meteoroid? And how about a comet? Well, let's take a moment for a little Space 101 to find out before you head out for your next night of gazing into the night sky. First, a comet. A comet is a relatively small object in the solar system that orbits the sun. And as you can see in this image taken at Stony Bridge Observatory, when they get close enough to the sun, solar radiation will cause them to have either a tail or a comma, a fuzzy outline. An asteroid is similar to a comet. It too orbits the sun. An asteroid, however, does not have a visible comma. Meteoroids are small rocks or particles of debris, usually smaller than an asteroid. When your meteoroid passes through and burns up in the Earth's atmosphere, it is known as a meteor. A meteorite is a meteor that actually makes it through the atmosphere and collides with the Earth's surface. One famous meteor crater, of course, is located right here in Arizona, just west of Winslow. Meteors do not make it through the atmosphere all that often. The world was stunned, however, by images of the meteorite strike just last month in Siberia. Mars, like our Earth, is also hit by these collisions. It was not until the high-resolution imaging science experiment, known popularly as HiRISE, was developed at the University of Arizona, that scientists could take detailed photographs to study such impacts on Mars. HiRISE is aboard the Mars Reconnaissance Orbiter, systematically photographing Mars's surface, including craters made by meteorites.
The recent event in Russia is an example of one that did mostly explode in the atmosphere, but with some spectacular effects and with some pieces making it to the ground. If that had been Mars' atmosphere that it went through instead of Earth's, it would have made a substantial crater or maybe set cluster of craters.
HiRISE's ability to photograph the same location in succeeding years has led to several discoveries. The appearance of topographical features since the first photograph indicates recent activity, including impact craters and the debris ejected onto the Martian surface.
So we've imaged more than 250 new impact sites. And an interesting thing we find with some of these is exposure of clean ice. The big surprise was just how clean this ice is. We expect, the first order you expect dirty ice. It's mostly ice-filled rock rather than ice itself, but this is mostly ice with very little rock material in it. Now, these are not necessarily all asteroids either. Some of them could be comets.
The camera is expected to capture images of 2 comets that will make close encounters with Mars in the next few years. Each HiRISE picture of Mars' surface contains 1 billion pixels, with each pixel covering about 1 square foot. The approaching comets will be farther away from the camera than Mars is, but will still be photogenic.
So one is called ISON, which is the acronym for the observatory that discovered it. And that is going to pass this year in October, relatively close to Mars, like 10 million kilometers, which means for HiRISE we get 10 kilometers per pixel. So that's probably not good enough to resolve the nucleus, but we can see the near nucleus jets and so forth. And a year later there's another comet that was recently discovered that makes an even closer, much closer pass to Mars. It's actually, there's a lot of uncertainty in it, but the prediction is 50,000 kilometers, which would give us a 50 meter per pixel resolution. We haven't really begun to formulate our plans for this Siding Springs comet in 2014. We need to learn more about it. Basically, it's like a targeted encounter with a comet that we send spacecraft for, only in this case, it's targeting us.
Much of what HiRISE has learned about Mars has nothing to do with asteroids or comets. Recently discovered features grow slowly over weeks, are only active during the warmest times, and are found only in the warmest places. They may be related to one of the most important scientific topics concerning Mars: water.
One area that I've been particularly interested in is something we call recurring slope lineae. Intentionally descriptive only name, but these are seasonal flows with many of them tens or hundreds or even thousands of them on slopes that form seasonally. On steep slopes, they grow slowly down the hill slope. And given that behavior and the seasonal temperature dependence, we think that briny water, salty water, is driving this activity. It's a flow of something down these slopes. It's not volcanic. We think it's either flowing water on the surface or seeping water in the shallow subsurface or some combination of those. But there could also be some sort of a dry flow triggered by water changing state in the subsurface or something more complicated like that. All we see are these dark lines that move down the slope, and then when they're active, they fade and disappear, and then new ones reappear the following year. And so this is just behavior where that's all we know about them. We're struggling to understand this. But so far, all of the hypotheses involve water in one way or another.
Between comets and meteors, amateur and professional astronomers alike have recently had a lot to keep them outdoors gazing at the heavens. This is a pastime, however, that may be lost to the next generation of children, which will spend more time indoors in the virtual world than out in the natural world. Joining us in the studio to discuss the implications of this new virtual reality is Meg Merill. She is the producer of Play Again, a film airing in the Loft Theatre this week, which asks the question, what are the consequences of a childhood removed from nature? What are the consequences of a childhood removed from nature? And I assume you're talking about them spending so much time behind the screen.
Right. Kids today are spending around 7 hours a day in front of screen technology. And one of the things that we're seeing is increasing rates in obesity. Our population, approximately 30% of us are now obese, and the rates for kids are rising all the time. We're seeing increased rates of ADHD, and we're also seeing more subtle issues that I think we need more study on, brain development issues, a lack of time to reflect, which many people believe is going to have implications for our ability to empathize.
And your film explores this topic.
Yes.
And we have a clip here that we can see.
All right.
This could be a social deficit for us in the future that could be really internally destructive to our country.
It's exhausting. Some physical effort, which, you know, it's fine, but it's like, makes you feel totally like out of it after it all. And then there's these bugs, these damn white bugs. If I had like just a nice can of like spray on like Annihilation, this would be perfect. Just spray it into the air, kill all of them.
Pizza Hut, a Pizza Hut, okay. Fried chicken and a Pizza Hut, a Pizza Hut, a Pizza Hut, fried chicken and a pizza. McDonald's, McDonald's.
Some of those images are quite disturbing. What was your experience taking these children away from all of that and thrusting them out into nature?
Well, it was a pretty amazing experience, and they all had sort of their own individual story and also a collective story as a group. So there were 6 kids that we follow in the film, and you'll have to see the film actually to see their stories. But they all had just incredible stories that were told with humor and authenticity, and they're an amazing group of kids. So I hope you get a chance to see the whole film.
So we saw, you know, this one boy obviously struggling with just sort of the visceral nature of being outside in the great outdoors. I mean, were they all having such struggles? I imagine that that's sort of normal. I mean,
Absolutely. There was a lot of struggle around control. A lot of these kids are used to having full control over their gaming. A lot of the boys talked about control in gaming and how out here in the real world, you know, one kid quoted, "It's so much more real out here. And in a game, you shoot a gun and you almost always hit your target. But in reality, they played bow and arrows in the movie. You shoot a bow and arrow and you mostly miss." And so there were a lot of really interesting reflections that these kids had.
So are you saying that their experience in the virtual reality world is in many ways so divorced from reality, the sort of the consequences of their actions are so separate, and that they don't necessarily distinguish that until they get out in nature? And that's kind of astounding.
I think it's different for every kid. I think they each have their own stories. So yeah, I think some kids are, well, they're not used to being out. So it's shocking for them to be out in the real world. But we actually were out in wilderness. So it was even more shocking for them than being at a park.
One thing about the online games I play are that when I play them, I'm usually running the show. I kind of like assume this role of like commander.
And why did you make this film?
Well, I made the film because I started off as a social worker, and I was starting to see a lot of families struggle with the issue of screen time and screen technology in their family life, and it's something that I'm very interested in. And the director said to me, well, why don't you produce this film? And I said, okay. And I went home and I Googled film production. And that was the beginning of my film production career.
Oh, that's astonishing.
So, yeah.
Oh, good for you. So,
yeah.
The time that these kids spend out there, I mean, some of it is also sort of an impression diet, right? I mean, we're so bombarded with all these impressions out here all the time. Did that play into it?
Well, absolutely. One of my favorite quotes from this film is a quote from Bill McKibben, who says, "Media teaches us that we are the most important thing in the world. And nature teaches us that we're just a small part of something very big." I think that really talks to the changing values in our society. And it was certainly something that we saw subtly in the kids at this camp. But I also want to point out that it's really important to recognize that nature connection doesn't have to come in the form of a week-long camp. There's a lot of things that parents can do to make a conscious effort to get kids outside, picnics in the park, eating dinner outside in the backyard, starting a garden. And I think a lot more parents are starting to recognize that we need to make these conscious efforts that we didn't have to make when we were kids.
Thank you for coming in today. Not only can you see Play again this weekend at the Loft, you can also watch it on PBS World on April 22nd at 5 p.m. World is available on Broadcast Channel 27.3, Comcast 203, and Cox 83. Thank you for joining us for AZ Illustrated Science. You can view this program or any of the segments again by visiting azpm.org. Thanks for watching.